Hello, fellow math enthusiasts. Today we're diving into the world of functions. Specifically, we're tackling two important concepts, codomain and range. These terms often get mixed up, but don't worry, we'll clear things up. By the end of this discussion, you'll be able to tell the difference between codomain and range like a pro. So grab your thinking caps and let's get started. Section 2. What is a function? Before we jump into codomain and range, let's take a moment to understand the fundamental concept of a function. A function is a special relationship between values. It assigns each input exactly one output. In simple terms, a function is like a machine that takes an input and produces a specific output. It follows a set of rules. These rules determine how the input is transformed into the output. Think of a vending machine. You put in money, the input, and select a snack. The machine processes your selection and gives you the snack, the output, based on the buttons you pressed. The vending machine operates under a set of rules that ensure you get the correct snack for the money you inserted. That's a function in action. Each input, like the money you put in, has a corresponding output, like the snack you receive. Each input has only one output. This is a fundamental property of functions. This is a key rule for functions. It ensures that the relationship between inputs and outputs is consistent and predictable. Understanding this concept is crucial as it forms the basis for more advanced topics in mathematics. Functions can be represented in various ways, such as through equations, graphs, or even tables. For example, a linear function can be represented by a straight line on a graph showing a constant rate of change. This visual representation helps us understand how the function behaves and how the output changes with different inputs. Similarly, a table can list input-output pairs, making it easy to see the relationship between them. By understanding these different representations, we can better grasp the concept of functions and apply them in various mathematical problems. So remember, a function is a special relationship where each input has a unique output following a specific set of rules. This foundational concept will be essential as we delve deeper into the world of mathematics. Stay tuned for more insights and explanations in our next section. Section 3. Understanding domain. In this section, we will delve into the concept of domain in mathematics, which is a fundamental aspect of understanding functions. Now let's talk about domain. The domain of a function is essentially the set of all possible inputs that the function can accept. It is crucial to identify the domain to understand the behavior and limitations of a function. The domain of a function refers to all the possible inputs the function can accept. These inputs are often represented as numbers, but they can also be other types of values depending on the context of the function. Going back to our vending machine example, the domain would be all the valid coin and bill combinations you could use. Just like a vending machine only accepts certain denominations, a function only accepts certain inputs. For a mathematical function, the domain is usually a set of numbers. These numbers can be whole numbers, integers, fractions, or even complex numbers, depending on the function. For example, in the function f of x equals x plus 2, the domain could be all real numbers. This means that you can substitute any real number for x, and the function will produce a valid output. This means you can plug in any real number for x. Whether it's a positive number, a negative number, or 0, the function f of x equals x plus 2 will always give you a result. Understanding the domain helps us determine what inputs are allowed in a function. This is important because it ensures that we are using the function correctly and not trying to input values that it cannot handle. By knowing the domain, we can avoid errors and make accurate calculations. Sometimes, the domain of a function is restricted. For instance, if we have a function that involves a square root, the domain would only include numbers that make the expression inside the square root non-negative. This is because the square root of a negative number is not a real number. Similarly, if a function involves a fraction, the domain would exclude any values that make the denominator 0, as division by 0 is undefined. These restrictions are crucial to understand to ensure the function operates correctly. In summary, the domain of a function is a key concept in mathematics that defines the set of all possible inputs. By understanding the domain, we can better understand the function's behavior and avoid errors in our calculations. Always consider the domain when working with functions to ensure accurate and meaningful results. Section 4. Exploring codomain. In this section, we will delve into the concept of the codomain, an essential part of understanding functions in mathematics. Next up is the codomain. The codomain is a fundamental concept that helps us understand the range of possible outputs a function can produce. The codomain is the set of all possible outputs a function could produce. It is important to distinguish between the codomain and the actual outputs, which are known as the range. It's like a bigger picture of potential outcomes. Imagine looking at a vast landscape. The codomain represents all the possible views you could see, even if you only focus on a small part of it. Think of it this way. The codomain is like a menu at a restaurant. The menu lists all the dishes the restaurant can potentially serve, even if you don't order every single item. It shows you all the dishes they could serve. The codomain works similarly, by showing all the possible outputs a function can have, even if not all of them are used. You might not order everything on the menu, but it gives you an idea of the possibilities. Just like in a function, not all possible outputs in the codomain are necessarily produced, but they represent the potential. Similarly, the codomain of a function tells us what kinds of outputs we might get. Understanding the codomain helps us grasp the full scope of what a function can achieve, even if we only see a subset of those outputs in practice. By exploring the codomain, we gain a deeper insight into the behavior of functions and their potential applications. This knowledge is crucial for solving complex mathematical problems and for applying functions in real-world scenarios. So, the next time you encounter a function, remember to consider its codomain. It will help you understand the full range of possibilities and make more informed decisions in your mathematical journey. Section 5. Defining range. Now, let's zoom in on the range. The range is a subset of the codomain. It consists of the actual outputs a function produces when given specific inputs. Going back to our restaurant analogy, the range would be the dishes you actually order and eat. It's a smaller, more specific set within the larger menu or codomain. In a mathematical function, the range depends on the function's rule and the chosen domain. Section 6. Codomain versus range A comparison. Let's compare codomain and range directly. Codomain, all possible outputs like a menu. Range, actual outputs for a given domain like the dishes you order. The range is always a subset of the codomain. In other words, every element in the range must also be in the codomain. However, the codomain might have elements not present in the range. Understanding this distinction is crucial for accurately describing a function's behavior. Section 7. Everyday examples. Let's look at some everyday examples to solidify our understanding. Vending machine. Codomain is all the snacks in the machine. Range is the snack you get based on your selection. ATM. Codomain is all possible withdrawal amounts. Range is the amount you withdraw, limited by your balance and withdrawal limits. These examples show how codomain and range apply to real-world scenarios. Section 8. Importance in mathematics. Understanding codomain and range is essential in various mathematical concepts. Function analysis helps determine if a function is onto, meaning range equals codomain or not. Graphing. Codomain helps define the vertical axis, while the range shows the actual values plotted. These concepts are fundamental for a deeper understanding of functions. Section 9. Conclusion. Congratulations. You've successfully navigated the world of codomain and range. Remember, the codomain is the set of all possible outputs, while the range is the set of actual outputs for a given domain. These concepts are key to understanding functions, which are fundamental building blocks in mathematics and beyond. Keep exploring, and you'll continue to unlock the wonders of math.